Welcome back, my fellow assassins, to another episode of the Dark Assassins podcast, the show that dives deep into not just technology, but the concepts, software, and procedures behind it all, and explains it so simply that even your grandma can understand it. As always, I'm your host, the Dark Assassin. Well, my fellow assassins, springtime is finally here. The flowers are blooming, the trees are finally getting their leaves back, everything is nice and green, the birds are back, they're singing, the temperatures are getting warmer, the days are getting longer, pollen is absolutely wrecking everyone, and wiping out all the hard work you did that you put in cleaning your car, only for it to get wiped out in a matter of minutes. Totally not speaking from personal experience on that last one. And finally, yes, unfortunately, with the return of spring, that means the bugs are back. I don't know about you, but the mosquitoes, for whatever reason, they just love me. They eat me alive every year. But the bugs aren't just coming back to eat you alive outside. They're also coming to invade your house. I know personally I've had to kill numerous spiders running around my house, and I'm sure you've probably had to do the same. But that's not the only place where bugs are coming. They're also coming into your code as well. Yes, that's what we're going to be talking about today. Today's episode, we're talking about bugs, specifically bugs in code, not so much the ones outside, because nobody likes those kinds of bugs. But in fairness, nobody really likes bugs in software either, unless it's a good bug. Then then it might be a good thing. But in general, we don't like bugs in software either. But I'm getting ahead of myself. What is a bug? When we're talking about software, what is a bug? So a bug, if you want to go with the proper quote-unquote definition, it's whenever your program experiences undefined behavior. Now that's just a bunch of mumbo-jumbo garbage. What does that actually mean? So basically that means whenever your code doesn't do what you want it to, that's a bug, put simply. So, for example, if you're writing a calculator application and you try to type in 2 plus 2 and you get 7, obviously something's not right there. So that would be a bug. That's a pretty easy example right there. So the next question comes, are all bugs bad? Well, it depends. If you want, perfect code to be executed exactly like you intend it, then yes, all bugs are bad. But sometimes you might find that if you're writing something more complex and you have depending on what the bug is, of course, it could be like, oh, that's pretty cool. And it might give you ideas for, something else to do. So they can definitely be really good learning experiences. Other times they can just be straight up harmless. Like if you think of bugs in real life, like ladybugs, for example, they're pretty harmless. They're not going to kill you. But sometimes you'll have bugs that'll just, randomly crash your program, or you just restart it and everything's fine, or they just happen rarely or something like that, and they don't really do too much. But then you have others that are super dangerous. We're talking like buffer overflow exploits, which that's a completely separate episode right there. But, these types of bugs that could completely cripple not just your program, but also your system as a whole. So if you have a bug like that, then yeah, that's super dangerous. So going back to the whole bug example, you have some bugs, in real life, like ladybugs, like I mentioned, that are basically harmless. And then you have other bugs that are like venomous spiders that you really don't want to mess with them. That's kind of like the same thing in software. You have some of your harmless bugs that, 2 plus 2 equals 7, like we said. Yeah, that's not a good bug, but, it's basically harmless. It's not going to destroy anything. But now say you had a bug where you took input from the user and they could, write system commands and it would just completely take over the machine that the code's running on, then yeah, that's a pretty bad bug, I would say. So the next question, I guess, comes is, will we ever get rid of all the bugs in our code? Well, it depends. Most likely, probably not, especially if you're going to be constantly updating this code and making constant revisions and adding features to it. you're virtually never going to catch all the bugs. Just like in your house, you think you killed all the bugs, and then 2 days later you see another one scurrying across the floor. It's kind of like the same thing with software development. There's actually a funny song out there. I'm not going to sing it, but I'm assuming most of you have heard the whole 99 bottles of beer on the wall, 99 bottles of beer, take one down, pass it around, 98 bottles of beer on the wall. So there's another one for software, which is it varies depending on how people say it, but it's essentially to the effect of 99 little bugs in the code, 99 little bugs, take one down, patch it around, 117 little bugs in the code. Essentially meaning that, like, you'll fix one bug and then it'll cause, like, 5 others to spring up or something like that. It's kind of funny. It is definitely true. Like, you'll fix something, and by fixing this one thing, you break something else. Then you have to go and fix that, and then that breaks something else. It's just a constant, bug chase going around your code trying to fix it. So, theoretically, yes, you could fix all the bugs. But as we'll get into a little later in this episode with some examples, even when you think you've got them all, there'll be like this one tiny little edge case that you didn't account for that'll just, wreak havoc on you, or sometimes just cause things not to work as they should. So yes, theoretically you can, but unless your software is pretty much set in stone and you're never going to add any kind of new features or anything like that to it ever again, probably not going to be able to catch all the bugs. Which, if you think about it, we'll also get into this a little bit later, but so many times you'll get like software updates, and even software updates that have feature updates in them, they almost always have bug fixes as well. And most, just generic updates, you'll see like, bug fix or security patch or something because, there are bugs in the code. So it's almost impossible to get rid of them. So I mentioned this a little bit. How do bugs come about? Like, how do they get into your code in the first place, I guess you could say? So the majority of the time, I would say, not all the time, but the vast majority of the time, the bugs that you run into most are those edge cases. Or, in other words, cases that require special handling compared to normal inputs. So I mentioned in the beginning of this episode of what is a bug, the calculator example. So when you're dealing with a calculator, you're expecting input that is just numbers, right? But if someone, inputs a letter or a string of letters or something like that, and you don't account for it, your program's going to crash. So that's what we would consider an edge case that you have to take into account. It's not something that would normally affect people or normally affect users of the program, but it's something that could happen, and you have to take it into account, which is kind of, where most, not all, but most bugs originate from, is these, edge cases that aren't the vast majority of cases, and most likely most people probably aren't going to run into. Another example of an edge case would be something that's pretty common, I would say, when you're doing testing of code initially, and you're trying to either do some kind of file input or output or load different types of data, which is where you hard code the path into your program, which just don't do that. Don't hard code the full path into your program. Do a relative path. And basically what a relative path is from the directory you're currently in, where is that file? So, for example, say you're in your source directory, and then inside your source directory, you have another folder called resources. Just do resources/file name. Don't do, if you're on Windows, don't do C:/users/your name/documents/programs. Don't do that. Just don't do that. just do the relative path. It'll save you so much headache. And this is, I don't know if many of you have heard this saying before, but it's so common in programming, in software development, especially in the academic world. I can't tell you how many times I've heard this from classmates and stuff, trying to give this excuse to professors and teachers where it works on my machine. Well, yeah, okay, sure. Yeah, and the dog ate my homework too, right? Um, or before, so I guess the first excuse was the dog ate my homework. Then it was my printer wasn't working, or I forgot my flash drive, and now it works on my machine. Like, it's just an evolution. Like, sure, it might work on your machine, but like, that's such a lame excuse. Like, come on, man. Like, don't be that guy. Just don't be that guy. Don't be the it works on my machine guy. Like, honestly, me and my friends, we joke about it all the time. Like, when when something like doesn't work, like when we're trying to like share code or whatever and it doesn't work, we'll just say in that mocking voice, "Oh, it works on my machine." Kind of a thing. It is funny, but that's usually like, just don't hard code paths. That's kind of another thing where bugs can come up, is like file not found or something. Check the path. Probably could be the reason. So another thing that I want to talk about these edge cases is, I'm not sure how familiar many of you are with the first few generations of the Pokemon games, and even now there's some. But the first few Pokemon games, specifically Gen 1, had so many bugs and glitches. It was kind of funny, actually. But the thing about the bugs and glitches is they were edge cases, and they're great, example of what edge cases are, because I would argue that even those of you who played, the older Pokemon games probably never experienced these, bugs and glitches and whatnot, unless you were actively trying to exploit them. Which, I mean, that's a good thing on the part of the software developers' part, that, for the vast majority of people, they never, ran into any issues or anything like that. So the first one of these is from the Gen 1 games, which is called the Mew glitch. And, well, it's one of the names for it. But really, you could use this glitch to get any Pokemon you wanted. But the reason it got the name Mew glitch is because that's how people, got Mew without having an event. So basically, I'm not going to go like super in depth on how this works, but basically the premise of this glitch, to set it up, is you would get in front of a trainer that would have to walk up to you, but you would keep them just off screen, and then you would take a step towards them, press the start button, and then either fly or teleport away from them, and then the game would think that you're in battle with them when you're really not. So when you go back to that route or wherever that they were located, it'll initiate a battle. So what you can do is you could fly or teleport or dig or whatever, get away from them, and then if you go battle a different trainer that has to take a step towards you to get out of like the, not really soft lock, but prevent soft locking your game. And then what you can do is, depending on the special stat of the last Pokemon you battle, every Pokemon in the game has a specific ID accounted to them, which is different from their Pokedex number. Depending on what that special stat is, you can encounter that Pokemon when you return to the route where you flew away from the trainer. So if that special stat happens to be the one on the trainer that you encountered to prevent soft locking your game, then you're fine. Otherwise, you can go find another one and battle it. So in the case of the Mew glitch, you had to find a Pokemon with a special stat of 21. If you found a different one, like say 14, that would give you Gengar, for example. So if you found a Pokemon, and there's guides all over the internet, you can look this up if you're more curious on diving deeper into it. But if you found a Pokemon with a special stat of 21, you could battle it, and then you also, if you really wanted to, you could use a move that lowers the opponent's attack, and that would allow you to catch a Mew or whatever Pokemon you're hunting for on level, if you did it 6 times on level 1, which also has some interesting effects, which we'll get into in a little bit. But you'd battle that Pokemon, and then you go back to the route where you flew away from the trainer, and then your start menu would pop up, close out of it, and then a battle ensues, and there's Mew at level 7. Unless you did the growl tactic or lowered the opponent's attack stat, in which case it could be on level 1. Now, the reason why that's interesting is because the Gen 1 games, they weren't meant to account for level 1 Pokemon. The lowest level you could find is level 2. So, if you have a level 1 Pokemon, what happens is the game doesn't understand how to handle it. So if you go into a battle and gain EXP on that Pokemon, you'll encounter what's called the underflow glitch, which basically instantly levels up your Pokemon to level 100, which is kind of cool. The only, I guess, downside you could say is that you can never learn any new moves aside from TM, so that's kind of a bummer. But like in the case of Mew, for example, if you didn't know, Mew can learn literally any TM and any move, so it really doesn't really affect you that much in the grand scheme of things. Plus, you have a level 100 Pokemon that you can just wreck everyone with, so like, big whoop. Even if you do only have like a pretty lame move, or I mean, you could teach it some other move via TM. And then another pretty well-known glitch, I would say, in the Gen 1 games is called the Missing No glitch, which you can also do this to get other Pokemon as well, but Missing No is the famous one. So also by doing this also does the item duplication glitch. So a lot of these glitches are like compounded, things that like build on top of each other, which is kind of interesting. So what the item duplication glitch was you can increase the item in the 6th slot of your bag by 128. So basically a lot of people would do this to like clone rare candies or TMs or Master Balls or whatever and just get a bunch of them. So basically the only, I guess, downside of this glitch is it can corrupt your Hall of Fame data. So if you care about that, obviously don't do it. But, I mean, it is still kind of funny, especially since a lot of the times that I've done the glitch, like you'll get a Pokemon that's over level 100. The only problem is if it's over level 100, it can still gain levels, but because you can't have a Pokemon over level 100, it'll go back to like level, I forget what it was, but it basically decreases down to basically nothing. So you want to limit how much you actually use that Pokemon, even though it's super OP or overpowered. So basically how this glitch would work was you would talk to the old man in Viridian City that does that shows you how to catch a Pokemon. So if you go talk to him, watch the demo, instantly fly or teleport or whatever to Cinnabar Island, don't go through any other routes or anything like that. And then if you surf on the east side of the island but keep along the shoreline, for whatever reason, that strip of ocean, the Pokemon that you'll encounter there is set up to be the place where you previously encountered Pokemon. So for example, a lot of people do this for the Safari Zone. So say if you're at the Safari Zone last and then you go here immediately, like from the Safari Zone, you can capture a Safari Zone Pokemon, which is helpful because Pokemon like, Chansey or Scyther, Pinsir, Kangaskhan, Tauros, whatever, they like to flee really quickly, but if you do try to catch them this way, they can't flee, so it makes it a lot easier to catch them. But anyway, going back to the Missing No glitch, because there's no previous area where you encountered Pokemon, the game doesn't know how to handle it, so it'll, generate this glitched Pokemon, which people call Missing No, because when you encounter the Pokemon, it literally says Missing No, like missing number, because it's it's a glitched Pokemon, which it's pretty cool. So another one of the Pokemon glitches, which is another pretty well-known one, I think, if you look into this kind of stuff like I've obviously done and do. It's from the Generation 3 games, specifically Emerald. Emerald, for whatever reason, even though it's a enhanced version compared to Ruby and Sapphire, has a surprisingly large number of glitches and bugs, which is kind of funny if you think about it. It's supposed to be like the better one, but a lot of the glitches in it don't exist in Ruby and Sapphire. But anyway, so this glitch specifically is what's called the cloning glitch. So this allows you to clone items and clone Pokemon. So how this glitch works is if you go to the battle tower in the battle frontier and you put the Pokemon or items you want to clone into the box, and then you save your game, take those Pokemon out of the box, and you go talk to the first receptionist person, and then, join either the level 50 or the open level, it doesn't matter. And then when it prompts you to save the game, you either soft reset or just turn it off and turn it back on again, and then your Pokemon will be cloned, and items will be cloned. It's pretty cool. So the reason why this works is because the software developers, I guess first off, they assume that people wouldn't do this, which is how it's kind of just an oversight, which is kind of it's kind of cool to see looking back, what were things that, they overlooked, that kind of thing. So what it does is it basically, before you save the game, it preemptively saves your party. But if you turn the game off, your party has been saved, but everything else goes back to where it was. So, your box is still saved with the original Pokemon, but it also preemptively saved your party Pokemon too. So now you have a copy of each, which is kind of cool. The one thing you do have to be careful about with this glitch, though, is I accidentally did it one time, which was kind of a bummer. I killed an Alakazam, which was really sad to see go. But if you do it in the opposite way, and rather than putting Pokemon in the box and then saving and then pulling them out, if you do it the other way, you pull them out, save, put them in the box, they'll be gone forever. Which, if you're really hacking and messing up the game and you end up getting what are called bad eggs, which is just corrupted data, it's a good way to get rid of them, because it's really the only way to get rid of them. So it's, it works out that way. But it's just something to be careful about. And then there's two other glitches in Pokemon Emerald, both of which are they both kind of build on each other. The first one's just kind of like a fun thing that you can do. It's called the Pomeg Berry glitch. So basically what the Pomeg Berry is Emerald, introduced, they actually gave some more, I guess, value or actions to some of the berries. So what the Pomeg Berry does is it raises the friendship of a Pokemon, but also decreases its HP EVs. And if you don't know what HP EVs are, and it sounds like I'm speaking a foreign language, don't worry. EVs are still kind of a mystery to most people, and they were definitely a mystery in Gen 3. But suffice to say, if you think of when you're going through school or learning anything, over time, the more you become accustomed to something, you improve in that certain subject or certain area. That's basically what EVs are. As you battle certain Pokemon, they'll give you certain EVs that boost certain stats. So, for example, if you're used to, if you walk a lot, you'll be able to walk further and you won't be sore afterwards. Just like if you lift weights, the more often you lift, and eventually you won't be sore after you lift, and you'll eventually get stronger and stronger. That's basically what EVs are, just for the specific categories for each, attack, HP, special attack, special defense, all that stuff. So anyway, what the Pomeg Berry does is it decreases your HP EVs, which has the side effect of dropping your HP stat. So what you can do in Emerald is, if you have a party of all fainted Pokemon except for one, if you use the Pomeg Berry glitch on the Pokemon that's still alive and it gets down to 0, the game won't white you out and take you back to the Pokemon Center. You can still walk around the overworld, which is kind of funny, which you're not supposed to do at all. But you can walk around the overworld with a party of fainted Pokemon, which is kind of funny. So this leads into the next glitch, which builds upon the Pomeg Berry glitch, which is called Glitzer Popping. Now, Glitzer Popping is a whole separate issue, and I'm not going to get into literally everything that you can do with this. There are plenty of good videos out there on YouTube that go really in depth on how this is done and how to set it up. But if you want me to go more in depth on this, I'll be happy to. Just, shoot me an email, link in the show notes below. But basically, what you can do with glitzer popping is if you set it up right, basically you get one of the in-game trade Pokemon, and you set its EVs, which we talked about. It's how good it is and improves in a certain stat. If you set its EVs to be at a certain level, and you use the cloning glitch, well, you don't have to use the cloning glitch, but the cloning glitch makes it a lot easier. So you set the EVs, you clone it if you want to make your life easier, and then you do the Pomegberry glitch to walk around with the fainted party, and then what you can do is you can enter a Pokemon battle, and it'll actually let you. You'll send out a glitched Pokemon with all question marks, which people in the community call Decamark. And then what you can do is if you go into your party Pokemon, select the first one that's fainted, I believe, and then you go back, you can infinitely scroll upwards, which is kind of interesting. You'll just infinitely scroll upwards, which what you're doing is you're corrupting data in your PC boxes, which is where the Pokemon you got with the specific EVs comes in handy. So if you get lucky and do it right, you'll overwrite data in your Pokemon boxes, and this allows you to get an egg. Usually you'll get a bunch of bad eggs, which, like I mentioned before, is just corrupted data, which you can use the reverse cloning glitch, where you take, instead of putting Pokemon in the boxes you want to clone, you take them out of the boxes to delete them, get rid of them that way. But if you get lucky, you'll actually get a legit egg. Now, what you can do with this egg is if you hatch it, it'll hatch into a Pokemon corresponding to the EVs that you set on this in-game trade Pokemon you got. So it basically allows you to hack in or glitch, or however you want to put it, any Pokemon in the entire dex. Now, the only caveat here is if you look at that Pokemon's stats and whatnot, the game just freaks out, glitches, and crashes. But the way you can actually get around this is if you put the Pokemon in the daycare and then you bike around until it eventually gets to the point where it's leveled up enough where it'll learn more than either 4 moves or more than 4 moves, then you can take that Pokemon back out and it's, perfectly fine to use. You might have some issues though if you're trying to trade it. The game might, get mad at you that it's not a legit Pokemon. I've had that happen before. Especially with like legendary or mythical Pokemon, you might run into this issue. Like I did it with a Mew and a Deoxys. Game wasn't having it. But the nice thing though, for Mew and Deoxys at least, you can set the glitch up differently, set the IVs of this in-game trade Pokemon differently. And if you set up your PC boxes correctly, which again, I'm not going to go super into because that's way beyond the extent of this. But basically, if you rename every one of your PC boxes to be a specific name, and you set the EVs to be a specific value, perform the Pomeg glitch, and you'll get an egg. Except this time, rather than hatching into a Pokemon, it'll hatch into Decamark again, which is that, weird question mark thing that I mentioned. And rather than being, being a random Pokemon, it'll actually warp you to a location on the map, which is pretty cool. So what this can allow you to do is warp you to the location or the islands where, you can get these, legendary and mythical Pokemon like Mew, Deoxys, Ho-Oh, Lugia, whichever one of the Latios or Latios, whichever one you didn't have as the roaming one. You can get those without needing any of the events, which is really cool if you, don't have a cheating device like I didn't and I don't, to be able to hack them into the game manually. You can, perform this glitch and get the Pokemon, and the game will see them as 100% legit because they are. You caught them at the place where you're supposed to catch them, so, the game's none the wiser. Sure, you did some weird exploits and whatnot, to get to that place, but, the game doesn't know that. which is kind of another thing which is interesting about this glitch. So basically, by renaming the boxes, when the egg hatches, it reads the names of the boxes. So basically, what you're doing is you're writing hex code, which I know this is probably going over a lot of people's heads, but just bear with me here. So basically, what you're doing is you're writing hex code, which essentially you're writing the exploit to tell the game, hey, warp me to this location. So when the egg hatches, it reads that code and it's like, oh, it just goes to, the next line of it just reads it as code as the next thing to execute. So it warps you to that location. Now, sometimes it does take some trial and error for sure, making sure that you got the box names correctly. If you don't get the box names correctly, your game will just freeze. The nice thing is you can just turn the game off, turn it back on again, and you're fine. But other times you'll get the box names correctly, but when you warp, you'll be slightly off of the island. It'll just be on water and you'll be stuck. So again, just turn the game off, turn it back on, and try again. But it's definitely something really cool. And I think, as a software developer, it's definitely kind of cool to see these kind of harmless bugs in, video games and in other software in general, just to kind of see what developers overlooked. And the reason I bring up all these Pokemon games is it's such a good example of edge cases and how easily they can be overlooked and missed. Because what developer at Game Freak is going to think, I wonder if the users are gonna rename all their boxes to be, this special stuff and perform this one thing where they can walk around with a bunch of fainted Pokemon, and if they set this specific traded Pokemon in game to have specific EVs and do all, who is thinking about that, right? I definitely wouldn't be thinking about that. I'm sure you probably wouldn't have thought about that either. I mean, I can't really knock them because, like I said, I don't know how I would have thought about that. And obviously, they didn't think about it either. So then we get left with these gems, which, some people call bugs, other people call them features. Which there's another saying out there where it's not a bug, it's a feature. Sometimes those are unwarranted remarks, people trying to defend their code, but other times, like in the case of, these Pokemon games, some people could see them as features, especially now when the events that you would have to legally obtain these Pokemon are no longer available. So you can just use the bugs in the game and get technically legal Pokemon through sort of, I wouldn't say they're illegal methods per se, because you're literally just taking advantage of the game. It's not like you're introducing a cheating device or anything. But, since these games came out, way before the internet was, really big, it's not like the developers could just push a patch to the game like they can on, the newer games where they can just push a patch. But which I kind of mentioned this earlier, the whole thing about software updates. Even nowadays, if you get an update that's just a straight quote unquote feature update, guarantee you there's bug fixes in there. Even if they're not explicitly said in the patch, in the notes for, what's new, there's 100% bug fixes in there. And a lot of the times, that's literally all the update is just bug fixes. So this is why some versions of particular pieces of software, specifically video games in this case, are really coveted by individuals and collectors because they contain, certain bugs or exploits or glitches or whatever that aren't in the newer versions because they got patched out. And, it, I know in the most recent Pokemon games, the not Legends Arceus, but Brilliant Diamond and Shining Pearl, they had some exploits in there in the earlier versions of the game that have since been patched out. So if through software updates, so if your game got updated, you can't perform those glitches anymore. So some people would see the older versions with have those, quote unquote bugs, or as some people would say, features, would no longer be available in the newer ones. So speaking of the whole bug, it's a bug, not a feature thing. I do have a story. I was when I was in high school, I had a project where I was working on where I was creating my own version of Snake, which is a video game. If you're not familiar, it's the one where you're this snake or worm or whatever, and you're kind of slithering around and you try to eat the little dots on the screen or the apples or whatever, and you grow bigger and bigger and bigger. So I encountered a bug where the starting point where the first dot was, once you ate that, for whatever reason, it would basically turn into a void spot or a place that you could go through, and it would just be black, and it'd be over the snake or the worm or whatever itself. So you could literally pass through yourself, which is kind of funny. And for whatever reason, I never figured out how to get rid of that, and obviously I haven't, gone back to it since. But yeah, at one point I just kind of gave up and was like, you know what? This is going to be a feature. It's not a bug. It's a feature. Yeah, so if you want to check it out, it's on my GitHub. If you search Dark Assassin 23 on GitHub, you'll see Snake as one of my projects. You can check it out if you want to. So another thing about bugs in general that I'll touch on is what's known as bug bounties. So what companies will do is they'll have like bug bounty programs, which is kind of what it sounds like. They'll basically say, hey, try to find a bug, try to find an exploit, try to find something that, breaks our code, and send it to us, and we'll give you either a cash reward or public recognition, or maybe even both. So basically the main reason for this is try to prevent, black hats or the bad guys from finding these exploits and either selling them to the highest bidder or writing exploits themselves. And this is kind of where you can encounter what are known as zero-day vulnerabilities, which are basically vulnerabilities that haven't been discovered yet but are, actively being exploited. So the point of this is to get the white hats, which are the good guys, have them, searching through this code and try to find bugs before the bad guys do. And that's really the main point of the bug bounties. So you can kind of think of the bug bounties if you kind of think, it's not a perfect one-to-one comparison, but think of the white hats or the good guys as, like a pest control company like Terminix or something. Terminix comes to your house, searches for bugs, and, kills them. And you hire them, just kind of like, which is kind of where I guess where some of the differences are. But, Terminix comes out and they kill the bugs for you. Kind of similar what white hat hackers, they're known as white hat hackers, are the good guys, or Terminix. What they do is, rather than the company specifically hiring them, they'll find the bugs, and rather than kill the bugs, because obviously they don't have access to the source code, they'll find the bugs and report them to the company, be like, hey, I found this bug. If you enter, XYZ into your search bar here, it'll give this weird undefined behavior, so, go ahead and patch that, something like that. And the company will take that information and then go ahead and patch their system. So that's kind of, in a sense, what bug bounties are, which definitely are good things. I've never found any myself, although I've never really tried. But obviously there are definitely people out there that are more qualified than me to find bug bounties. Plus I have other things to do, like record this podcast. Yeah, so I think it's probably going to do it for me today. If you enjoyed this episode, I'd ask you to please leave a rating and review either on iTunes or Spotify, or wherever you're listening. Share it to a family or friend that you think might enjoy it. If they're a Pokemon fan, they might be interested to learn about some of these bugs that are in maybe some of their favorite games. And if you have any questions, feel free to leave a question in the rating and review, or you can shoot me an email at contact@darkassassinsinc.com. Link's also in the show notes below that you can click on that. And that's going to do it for this episode of the Dark Assassins podcast. Until next time, my fellow assassins, remember, bool nothing equals true. If action not equal to null, return true. I'll see you next time on the Dark Assassins podcast.